Hey, everybody. Good evening, and it's been an awesome conference. I'm really honored to be here. I'm the last speaker, so the beers are just down the block, around the corner, so afterwards we can all go and drink our sorrows away. How do you all like the extremely well choreographed live photograph that I took for this? It took me so long to get all those people standing in a circle. It's good, right? Okay. So I want to talk to you all about where I kind of see our entire industry going, given that we have this new alien technology that just landed in our backyards a couple of years ago called large language models. And if you don't know what large language models are, you've clearly been living under a rock. So surprise, it's 2024 and we're all going to be out of work in a few years, right? So let me just dive right in. So first of all, who am I? I think it's important that I give you a little bit of background so that you know whether to pay attention to the rest of the talk or not. I give that as your discretion. So I've been around for a while. I've been writing code since 1984 on a VIC-20. VIC-20s had 2K of memory. That was exciting. I wrote a book about Linux way back in the early 90s, went on to Berkeley, was a professor of computer science for a while, took leadership roles at Google and Apple, Octo.ai that just got acquired by NVIDIA, by the way. Have done a few AI startups. But really, I think the thing I'm most proud of in my career, and this is really the crowning achievement, is speaker at GOTO Chicago 2024. Yes. Okay, but what this kind of means is, I've seen some shit. And what, I was thinking about this as I was putting together the deck last night, and, all of this is to kind of say, yes, I'm obviously a dinosaur, but also to just imagine how different the world is now from 20, 30, 40 years ago when I started interacting with computers. And I've been really fortunate, a lot of us in the room have been really fortunate to live through what I think of as multiple revolutions of computing technology. I never really imagined I'd live through all of these revolutions, right? When I was a kid, in the 70s, we had a little Pong, thing with the paddles, and you plugged it into your black and white television, right? Had an Atari 2600 as a kid. Saw the PC revolution happen before my eyes, like was living in there, like with the Apple IIe on my desk in my bedroom and writing Pascal code and playing Ultima 4, right? We took a little bit of a segue away from good computing into Windows 95. We'll just kind of maybe, I've blanked that whole decade out, I hope. You have too. But the early web, I was like on the web like super, super, super early, and the reason I knew about the web, I found out about the web, I was in college, and I started to notice these HTTP things showing up in people's email signatures and their signatures on Usenet. He's like, what the heck is HTTP? And I had no idea what it meant and how to, what was it a reference to? Some kind of geek code. It was a geek code. And then, I bought the first iPhone when it came out, the day it came out or whatever it was in, 2007? So I've seen all these revolutions happen, and so I think I should be pretty well attuned by now to what does a computing revolution look like, having lived through several of them. And I don't think I'm exaggerating when I say that AI and language models is like far more profound than any of these things like put together. And it is such a huge change, and I think that's why you hear all this hype around it, right? And yes, I'm hyping AI in a big way, and people are probably kind of sick of hearing about the hype by now. I don't blame you. I am kind of sick of it too, but it's a real revolution that's happening right before our eyes, and it's happening so fast, not like PCs. PC revolution took more than a decade because people had to go out and buy this thing, and bring it home and clear off a desk and put it down and plug it in and learn how to use it. And it was a major expense. And now with Gen AI, you just put the app on your phone, right? It's just like instantaneous that everybody can get access to it. So we're all software developers, or most of us in this room are software developers. I count myself here. I've already established that I'm a dinosaur, but I kind of want to make the claim here that we're all dinosaurs. Every one of us in this room is a dinosaur sitting at our laptop doing our job. We're writing JavaScript or Java or script, whatever that language is. And what's going to happen here in the next, really it's already happened, I think it's hitting, but the meteor is going to hit, right? Giant OpenAI logo in front of a huge flaming fireball coming out of the sky. This is upending the entire software industry, and we can see it unfold before our eyes. And I think we have a few reactions that we could adopt here. One is to, run screaming for the hills. Another is to pretend it's not happening, bury your head in the sand. And the third might be something that we say, hey, this is actually a huge opportunity for the entire world's population, not just for us as software engineers, but as, bringing computing to everyone. So let's rewind a little bit. We've been doing computer science for about 50 years. Okay, that's how long this field has been at it. And it's always been about just really one thing, which is taking some idea, an algorithm, a data structure, a concept, an architecture, and translating it into a computer program. That's computer science in a nutshell. That's what it's always been. And those computer programs are intended to run on what we think of as a von Neumann machine, right? A machine with a processor and memory and stored program and registers and all of those fun things. And that's the whole field of computing right there in a nutshell, translating ideas into programs. So the problem with this definition of computer science is that it has always assumed that the programs that we're talking about have been implemented, maintained, and understood by humans. That, I'm a human, I write a program, I share the program with you, you are another human, you read the code, you understand what it does. We can maintain it together. We can find the bugs, we can fix the bugs, we can ship it to customers. That people are always part of that process very intimately. But as I've said, computer science has been around for 50 years. We absolutely suck at those things. And I do not believe that any amount of new programming languages, new tools, new debuggers, new documentation tools, new, Sphinx plugins or whatever is going to change that. I think we've had the experiment running for 50 years, and the bottom line is writing software is hard and humans are bad at it. That's the answer. We have plenty of data points. So I think we need to recognize that we're not just, Rust 2.0 is like around the corner, it's going to solve all of our problems for us. But believe me, there are countless people, many of whom are in this room, that are dedicating their lives to solving that problem, to chipping away at it. Let's make documentation better. Let's make tests better. Let's make type systems better. And unfortunately, I think it's probably a failed endeavor at this point. So at the same time, something new has happened, is that we've got a completely different way of, scare quotes intentional, programming now. And that is to instruct a language model to take in some input, do its amazing magic language model stuff to it, and produce some output. So this is a snippet of actually I launched this a couple of weeks ago. I didn't put the URL up here, but I have a site that takes in an RSS feed of a podcast, and it will transcribe it, summarize it, identify the speakers, generate a chat bot, put up the whole thing on a website so that the podcast owner gets like a AI-enhanced podcast at a click of a button, okay? I think it's kind of cool. Go check it out. But this is part of the code. And the code is like, provide a 1 or 2 sentence summary of the following segment of the podcast transcript. Please only use information in the text. Don't infer anything, just look at what's there. Include the title of the podcast and the name of the episode and the names of the speakers. This is one of the prompts in my program. Here's another one that's a little more interesting. It's take the podcast transcript, and the names of the speakers are not known. When you pass the audio through the language model, through the ASR model to get the text, it doesn't know the names of the individuals speaking. So it says speaker 1, speaker 2, speaker 3. But I want to show, Ken and John and Diana. Turns out that's trivial for the language model to do, right? You give it the transcript and you say, tell me who all these speakers are. And it can figure it out. How? Well, obviously, right? If you were reading the transcript, you'd say, oh, that one person referred to that other person by John, therefore that person's name must be John. That kind of thing. And by the way, I want you to format the response in JSON, and I don't want you to do all this other stuff. By the way, this only works if you capitalize do not in all caps. Those are load-bearing caps, right? If I don't have the caps in there, it doesn't work as well. Okay, so this is awesome. And so much of the code, quote, air quotes are on code, that I write now is like this. It is English instructions to a language model. And I think we're at the very beginning of what's possible there. But we have a big problem, okay? If I were a dyed-in-the-wool conventional computer scientist, which actually I am, right? I would have to ask the question, well, hold on a minute. Let's view this through the lens of computer science. What is the algorithm that this is implementing? How would I write this algorithm down as code, preferably in LaTeX in a research paper somewhere, right? And what could I prove about this program? Those are the main ways that computer scientists look at programs. Those are the main things that they want to understand. And I posit that not one person in this world could describe this 6-line prompt formally as an algorithm, right? But how many of you understand that prompt? It's like, I would expect all of you understand what it's doing. If I gave these instructions to you with a printout of the transcript, you would have no problem doing this. The language model has no problem doing this. So I have a computational object here that I can't write an algorithm for. The computer scientists are freaking out, right? Because they don't have the tools to think about this. None of us do. I say they, I mean we. We don't have the tools to think about this. So this should tell us something. This should tell us that there's something big happening when we start using language models as computational resources, as part of programs, but we can't apply any of the conventional computer science tools to them. And to me, that's both scary and exciting. So, The Art of Computer Programming, I own the full set of books. I'm just going to go home and chuck them in the fire, right? Because it's totally useless. Nothing in any of those books is going to help me understand that, right? And this is not Donald Knuth, but I don't think Donald Knuth ever had a beard, but ChatGPT seems to think he did. Anyway, okay, so we have another interesting shift happening in our field, which is for decades, the act of writing a computer program and having the skill to write computer programs has been like hard won. You got to go to college for 4 years in most cases. I went to college for 8 years if you count, or probably 10 if you count my PhD, right? Or you got to work in industry for a long time. This is not a skill that you just sort of like pick up, right? So it takes a lot of time, it takes a lot of money to get trained like this, and I think it still takes a fair bit of intelligence. I mean, I said we all suck at writing computer programs, right? But some of us suck more than others. Okay, so the other interesting tidbit, which is And you wouldn't be surprised that, of course, a skill that is very rare, that takes a lot of time and intelligence and money to acquire, would demand high paychecks for people who can do it well, right? And the average salary of a software engineer in San Francisco, that's average, is $175,000, right? It's a huge amount of money, frankly, right? Maybe not if you're living in San Francisco, but you get my point, right? So I did ask ChatGPT to make like all the images in this talk, and I said, show me the priesthood of programmers. These guys have those fancy new monitors with the code on the back. Those are really cool. And there's sadly one thing that ChatGPT got right, is that they're all men. This kind of sucks, but I did say priesthood, so it's a little biased. Anyway, okay, so this is a little weird. We benefit from it, though, right? Don't we? Because we're making that kind of money. That's one of the reasons we can afford to come to Chicago and come sit here for a couple of days instead of doing real work, right? So this is a thing that our industry is maybe going to have to contend with, that perhaps this will not be a rare skill set anymore. And what does that mean for our field, right? We've got a world population now of about 8 billion people, out of which that little green sliver is the 30 million people that, and that's a generous assessment of programmers, people who can write computer code. 30 million sounds like a big number until you compare it to the rest, right? It's a tiny little sliver. And so this seems problematic to me for a few reasons, one of which is that those 30 million are the bottleneck for the rest of the world getting access to computing, because those 30 million decide what everybody else gets to do with their computers, right? We're the priesthood. We're the gatekeepers. But this wasn't how computing was supposed to be. When I was a kid and you got the Apple IIe, every one of these things came with a basic programming manual. And I mean basic in all caps, the programming language, right? The idea was you were expected to program it. Everyone was expected to program it. You weren't going to get a computer and just like, what were you going to do? You turn it on and it gives you a prompt. What can you do with it at this time? 10, print hello, 20, go to 10. You have to program it to do anything with the computer. And this is interesting because this is an ad from Apple from like the 80s or something. And you know, what is she doing here? Anybody recognize it? Logo, right? She's programming. Or she's running the program that one of those other people wrote, whatever. But they're programming. That's what it's showing, okay? And I am probably incredibly naive and nostalgic, but I pine for those days when the idea was that we could all program. Anybody could program. Programming was not, you know, I have 2 kids. I've tried to teach my son how to program, you know? And it's like, okay, so we're going to sit down and do this cool thing. What do you want to do? We want to do this cool thing. Okay, let's start with NPM versus yarn. Little 10-year-olds, oh no, what is this, right? So we're all kind of dealing with this like complexity that it's like logo or basic. You just dove right in, you started writing code, you could just do anything immediately. I want that back. And I'm reminded of Steve Jobs' famous quote about thinking about the bicycle, the computer as a bicycle for the mind. And this is the actual quote. And he was using a reference about what is the most efficient way, the most efficient means of travel from one place to another known in the natural world. Right? And if you count like the number of calories or whatever it took and the amount of time it took to get from one place to another, that a human on a bicycle is the most efficient thing that nature has come up with. And the bicycle is sort of second order because people invented the bicycle to ride, but I still count that, okay? So he was referring to a computer, a personal computer, as a bicycle for the mind to enable all of us to extend and enhance our intellectual abilities. And I think that's actually very true. I think any one of us would agree, right? So This, to me, is such an exciting opportunity. It makes me wonder, what if everyone on the entire planet could program? And I don't mean program in JavaScript or Python, and sure as hell not Rust. I mean, get a computer to do the thing they want it to do, not the thing the engineers at Meta want them to do, but the thing they want it to do. Because after all, the computer, and I'm including phones and watches and other stuff in that, they're fully general programmable devices, aren't they? Right? My laptop is not built in with 5 programs and that's all it can do. Right? This is not like buying a blender or a electric toothbrush. This is fully general. This computer sitting right here can do anything, maybe really slowly, but anything. It can do anything. But we've taken that ability away, right? Or we haven't unlocked it for people at least. And for most people in the world, when you ask them what computing might mean to them, it means, I have a phone. What do you do with the phone? Facebook and WhatsApp. You know, and I've been all over the world. In my former job at Google, I led some of the engineering efforts around bringing the web to the rest of the world. And we would go to country after country after country and talk to people about how they use their phones, how they use the internet, how they use the web. Guess what? Nobody even knew what the web was. Many of them are like, the web? Right? This is 2019. What's the web? I've got Facebook. So that's what I see as an opportunity for all of us. And the question is, how do we unlock it? Right? And I think we now have the tech. I think the tech is coming, or it's here already. We need to figure out how to use it so that anybody can take the computing power that is in their pocket, which is substantial computing power, and really bend it to their will, get it to do what they want to do. And I actually think that is a huge opportunity for all of humanity, if we could unlock that. And I think we can. Does anybody remember this project called One Laptop Per Child? I mean, they kind of had the right idea. They didn't execute it correctly, in my opinion, but they had the right idea, which was we need to ensure that the next generation of people, especially people not living in a place where they're already, like, you know, my house, I've got 6 laptops lying around, and if my kids wanted to go use a laptop, they have no problem getting their hands on a laptop, right? In most parts of the world, a laptop or anything of that form factor, and one laptop per child was a little bit before smartphones became a real thing. Now you can buy a smartphone for $30, $40, and that changes the landscape. But back then, they wanted to build these laptops that were extremely robust, very hard to break, simplified user interface, simplified OS. You could turn a crank to power to charge it up. You didn't even need to plug it in, okay? And I think they did a great job at showing what might be possible, and I think the mission was the right one, but unfortunately it failed to deliver on the promise, in part because of where the technology landscape moved. I think the other problem is that they learned how to play League of Legends on it and just, you know, sort of screwed up. Anyway, all right. But I already know what you're thinking, which is, gosh, you know, this is all great, peace, love, and joy, but AI is taking our jobs as software engineers, isn't it? And I think it's undoubtedly true. I think it's scary, but I tend to believe that if technology plays out the way that we've seen over the last just couple of years with LLMs and the integration into developer tooling and all those things, there are ultimately going to be a lot fewer programmers in the world. And the programmers that are left are going to make a lot less money. That's just my belief. And it might take 10 years, it might take 15 years, it might take 4 years, right? We don't know. And I think people are justifiably skeptical. Most people are skeptical of this because they're like, well, I tried Copilot and it sucks. Like okay, so think about it this way. When you are on an exponential, it looks like you're going on a linear path, doesn't it? Right? So based on what you've seen the last couple of years in this space, you might go, nah, this stuff is never going to get that good. But I tend to think we are actually on an exponential, and we're going to get a point not too long from now where, and we've already seen plenty of demos of this, I can just go straight to ChatGPT and say, write me a program that does this thing, and it does it. Okay, it still takes me 2 hours to get it working, but I can see where it's heading, right? And I think we can all see where it's heading. At the last few companies I've worked at, I've absolutely insisted that every engineer use Copilot and every engineer have a ChatGPT account that the company should pay for, because we see it as such a huge accelerator, but also because I want the surface area between the humans writing code and the new AI tech to be maximal. I want them using this stuff all the time, and the reason is it changes how you think about problem solving. The number of times that I have saved days of work by asking ChatGPT to do something for me, I've just lost count of. I'm trying to get this funky authorization library to work with this React component with this internationalization library. Who around me knows how to do this? Nobody. Shit. Go read the documentation. No one talks about how to do this. Maybe there's a Stack Overflow post that's probably wrong. But then you go to ChatGPT. Hey, I'm writing TypeScript code using the blah blah library with this other thing, and I want to do this, this, and this, and I'm having a hard time putting it together. And it goes, yeah, sure, no problem. Here you go. Here's the example. Boom. It's not like I paste it in and it works. I have to tweak it, but oh my God. Right? So I think that if you're not recognizing this, if you're not using this tech, if you're not experiencing this for yourself, you can be somewhat forgiven for not being aware of what's the meteor. But the meteor is there, whether you like it or not. This is not, of course, the first time that we have had to have a huge industry shift because of the introduction of new technology. And for a beautiful story about this, which I'd highly recommend everyone go watch. I think it's on YouTube. There's a little mini documentary, I think it's 20 minutes long or so, from the New York Times called Farewell Etaoin Shrdlu. And this tells the story of the last day that the New York Times used hot metal typesetting, okay, linotype machines, that literally cast the letters from lead or other metals in real time, and you type, and it produces the metal type for you that you need, and they load it into frames, and they print the newspapers with that. And this has been the way of doing newspaper printing and book printing and everything else for like 100 years, right? And then computers came along, screwed it all up, right? So this documentary is great because it captures that moment in time when you see the shift happen literally overnight from going from linotype to computer phototypesetting. And all of these people who had spent their entire careers sweating away in this hot, loud room with these clacking machines with hot metal sputtering out of them had to go learn how to use the computer typesetting machines instead. I cannot tell you that they were happy about this necessarily, right? Because this was their lives. But it's just one example of how we've had to make this transition in the past, and the world has made these transitions before, and yes, things change. So with all of this LLM stuff that I'm talking about, the question might be, what happens to conventional programming? And as I said earlier, we're used to writing programs that are meant for a von Neumann machine to run. But what if you could just give a language model a job to do, and it did the job? There's no generating of code. Just skip the intermediate step, right? Don't go from English to code to running it. Just go from English to running it, right? The language model can often do a better job than having to generate code first. And I think this radically changes how we think about computation. So I like to think of this as like a new kind of computer architecture, Okay, call it the natural language computer. I'm not the only person who's used this term. We start with our natural language program, which is English, or some other natural language. We're not English specific here. And the language model has external tools. It can go out and browse the web, or it can access a database, or call an API, or whatever. As it operates, it can build up a list of tasks to perform, so it can set goals for itself and choose what makes sense to do next, and maybe explore a few different ways of solving a problem, a lot like we would. And of course, it has some memory, so it can store both short and long-term things using a vector database or some other mechanism. So when you start to look at it this way, kind of, imagine back in the 90s, it was Intel inside. Now it's ChatGPT inside, right? And, I do think that this is an interesting way of thinking about where the future of computing is going. And so, for 50 years, it's been about von Neumann architecture. Now it's about the natural language machine. Let me give you an example of that. And this is, I started working at this startup called Aryn, so forgive me for the sponsorship here. But one of the things we're doing at Aryn is effectively building a natural language computer for solving a very specific kind of problem, which is allowing companies to take a huge pile of messy, unstructured documents and run analytics queries on them. So this is not the same as search. Search would be, I'm looking for a document, give me back the most relevant stuff. This is more analytics, like go through all of these documents and tell me what were the main causes of equipment failure in the Northeast region in the last 5 years where human error was involved. That's a pretty gnarly query to run. And if you already had all that data in structured form, you could that would turn into SQL or something, right? But this stuff isn't structured. It's Word docs and PowerPoints and PDFs and text files and emails flying around. It's a mess. So effectively what we're doing at Aryn is making it possible to do this using the natural language computer architecture inside. Those of you who've been playing with AI probably know about RAG. Here's my hot take on RAG, which is RAG is hot garbage. Okay, and I'll tell you why. RAG is this technique where you go and you say to a vector database, give me the most relevant stuff for this query. You pull out that relevant context and then go to the language model and say, okay, now figure it out. Right, so if the user says that complex thing I said earlier, what were the most common causes of equipment failures in the last 5 years or whatever the example was, I go through my pile of documents, I lift out little snippets, I compose all of those snippets into some mega prompt, I shove that prompt down the throat of ChatGPT or whatever language model and say, what's the answer to this question? And this doesn't work for a bunch of reasons. I mean, it works in some cases, that's why it's been so successful, but it doesn't work in cases where you got way too much data, right? The prompt windows are limited in size. The context is split across many different things, that there's not like one chunk of information that holds the answer you're looking for. And it basically just punts on the hard computational problem and says, hey, language model, you figure it out. Good luck. So what we do at Aryn is a different technique, which is called Luna. Luna stands for LLM-powered unstructured analytics. And with Luna, we're using LLMs for sure, but we're doing it in kind of a smart way, I think, where we're asking the LLM to do two things. The first is take this English query, turn it into a query plan. Now, that query plan might consist of just conventional computational operations like a count or a filter or aggregation, but it also might involve LLM-powered operators like look at this document and tell me whether or not severe injuries were involved. Right? That's a semantic operation. Now, the LLM is good at that. You give it one document and a snippet of text and say, were severe injuries mentioned here? And it's quite good at giving a good answer to that kind of question. But the point is we're using the LLM in a kind of focused way. We're not just dumping a ton of crap at the LLM and say, give me the answer. We're saying just one doc at a time, give me the answer. And it does a good job, and you coordinate that, and you can get a pretty good result. Okay, so end of commercial. Right, so how do we get there? So I see really three big barriers to universal computing. The first is the high cost of LLMs. The second is that they suck at speaking languages that are not languages that you and I speak. And third is integration of these things into the real world. So I think we all know this, right? So let's just take a quick peek at the median income per household in several countries around the world. So with the United States, Japan, France, it goes roughly like this. This is median per household income. And I'm choosing median because I don't want to count Elon Musk, okay? And I chose adult population because I don't want to count Elon Musk. Okay, anyway, so people in these countries can afford $20 a month for ChatGPT, generally. Not everybody, but enough of them for it to make sense. But how about India? By the way, the population is way bigger than most of these other countries, and the median income is way lower. And again, I'm just talking about medians. You know, there's all kinds of other statistics we could talk about. Indonesia, 186 million people live there. Most people, like, if you go ask people about, like, where's the population in the world, like, most people are going to forget to mention Indonesia. It's huge. I chose Democratic Republic of the Congo as the last one because it is the lowest in the world at $532. That is annual, right, per household, annual. They're not buying ChatGPT there, okay? Nor should they have to. And but they're just a little African country. I don't even remember where they are. There's 42 million adults who live in that country. It's huge, right? So I think we have to remember these numbers. A lot of people said, well, why don't you just like run the LLM on local hardware? That way you don't have to pay OpenAI or whomever to run it for you. But these language models do not, the good ones anyway, do not run on cheap hardware. Okay, you know, if you have to buy a quad GPU machine, right, to run the model, and every household needs one of these, that doesn't work out either. Okay, so we can't just say, well, this is the answer, give everybody a box. Okay, another big problem is these language models are pretty good at some languages, but they're just downright awful at others. So this is data from a paper, the link is down at the bottom, showing the accuracy of the Llama 2 7B. And I'm just using this as an example. You're going to get different numbers for different models, right? And there's newer models, and this paper is a couple years old and all that. But the trend and the point, I think, are still hold that, you know, languages like English, French, and interestingly, Indonesian and Vietnamese actually do quite well. There's a lot of training data out there for those languages. But then it falls off really rapidly. And, you know, you get to languages like Lingala, which is one of the, you know, main languages spoken in DR Congo that I mentioned earlier. Bengali, Japanese is not that great, right? So it's a little surprising. You would think it would be better. Oh, but these are all weird languages, right? Telugu, who the hell speaks that? Something like 94 million people. Right? These languages are huge in terms of the number of speakers, huge numbers of people. And we have to think about that. I mean, Amharic is the worst on this benchmark. And that's spoken in a place like Ethiopia, and it's 60 million speakers. It's not a small number, okay? So if we're talking universal, I really kind of mean it. I mean universal. I don't mean, oh, universal, but you mean English, right? No. And French, maybe. No. I want to cover all of these. And then the last point is being able to interface AI to the real world. And I think part of our challenge is we tend to think about using AI and language models today through the lens of sitting in front of ChatGPT and typing stuff at it. And it types back to us. And that is super powerful, but I don't think that's how most people in the world are ultimately going to interface with AI, right? So how do we unlock universal computing? Well, we got to go way beyond this kind of thing. I think real-time voice is going to end up being huge, huge. And how many people here have played with the latest advanced voice mode in ChatGPT on the app? Only a few? If you have not tried this, go get a bottle of whiskey, and you might have to sign up for something. I'm not sure what happened to my screen. And go try it out. It is jaw-dropping. You can say to it, read a Shakespearean sonnet about Star Trek as though you are out of breath. Right? And it'll be like, and it'll do that kind of thing. It's amazing that it can do that. Okay, another plug, the company Fixie that I started a while back, but have since left, they have built out a model called Ultravox. And what Ultravox does is, instead of taking in audio, going to text, going back out to text, and then out to audio again, it goes audio to audio. There's no text intermediary. And that is so cool. And the reason it's cool is, well, first of all, it reduces latency, right? And if you're going to have a conversation with an AI, the latency needs to be good. The second is, if you translate audio to text, you lose so much information, right? Because if I go to my AI and I'm like, I really need some help here. I've got an event to plan. And I'm not, I need your help planning this event. And it goes, that's great. And I'm like, yeah, it's my dad's funeral. Oh, it loses all of that nuance because it didn't hear the tone of voice. It didn't understand the context in which you were speaking. And now we can actually do that because audio to audio retains all of that meaningful semantic information carried in things like tonation and diction and all of that. And then the sort of final bit here is, this one drives me insane. I don't know why this doesn't exist. But it really feels like I should just have a language model built in here, and that language model should be able to do everything that I can do with my websites, my apps, my email, everything that's already on my computer, because my computer has all my credentials. It has all of these fantastic, amazing tools. But today, when you ask a language model to do something, it's like, well, I don't know, I need to generate some Python code or something. It's just sort of like there's this huge gap. So we're now at the point where this is possible. I don't know why it isn't yet really a product, although I see Microsoft doing some stuff in this direction with the Copilot in Windows. But it feels like I should have been able, and this is getting a little meta here. I actually made this slide while I was working on the deck, and I should have been able to say to the AI, finish the talk for me. But this is sort of wrong too, right? Because what did I say earlier? Most people in the world are not interacting with this kind of computer. They're interacting with that kind of computer. And this is where stuff gets really exciting, because if you could actually get a language model to understand everything that I'm doing on my phone in the context around me and the voice and what's on the screen and what I'm taking pictures of or whatever, and control all of the apps and things I've already got on the phone, poof. You've got an amazing, amazing product right there. Okay, so I'm going to wrap it up. So basically, computer science, for the longest time, the slide rule was the tool of choice for all engineering disciplines. If you did not know or use a slide rule, you were dead meat. Everyone used a slide rule. How many people here know how to use a slide rule? That's actually way more than I would expect. So I have one here. I'm going to have you, no, I'm kidding. But I actually own one, but I don't know how to use it. This might be what, in a decade or so, we kind of imagine has happened to computer science. That this is our mental image today, is the guy with the cool AirPods, sitting in front of VS Code or whatever, right? This might be going away. And so what does that mean? Well, it's possible. One path is that computer science as a discipline looks more like EE. EE is still extremely relevant. You know, I wouldn't have all the beloved M2 chips on this laptop were it not for some really smart electrical engineers. But do we all need to be electrical engineers to enjoy the benefits of computing? No, of course not, right? So I think, you know, CS might just stick around, but as a much more specialized and deeply technical skill set, rather than just sort of paving the world with software engineers like we do today. The other is, I do think that the most people that we think of as building software are not going to be programming. I think ultimately they're going to be instructing or teaching an AI how to do things. And that's, you know, we see that evolving right now. And then, you know, as I hopefully have left you with this idea is that, you know, AI can greatly expand access to computing. And I'm excited by that. It is scary for the field, but if everyone can get computers to do what they want to do, I think this is a net good for all of humanity, and I think we should all strive for that. I think that's something we should all want to see happen. So I started the talk by basically saying computer science is dead, it's all doom and gloom, and hopefully I'm wrapping up with everything is awesome, and let us all bow down to the beautiful OpenAI logo floating in the sky. And I'll wrap up with this, which is back in the 80s, John Gage for Sun Microsystems said, the network is the computer. I never quite understood what that meant. But the network is the computer. I'm here to tell you the model is the computer. Right? So the way we think about computers in the future may be through this lens. Okay, thank you very much.